All right. So if you guys notice when you log in, if it doesn't say that, just remind me. I just don't take off the filter. Okay, the background, right? Okay. I don't do filters. Yeah, all right. Sorry. Which part of that equation up there is the error? It's kind of, I don't know how I can describe it, but the Z part, I'll take that. This whole part here is the error. The book likes to call this error bound, which sounds like I'm headed out, I'm error bound. Yeah, okay. But that's what the book calls it. It's kind of like the maximum error expected at a certain level of confidence. Oh, shit. So when the book asks you to find the error bound, the really funny thing is, I want to remind you about something. This book is unfortunately built on, it's built for teachers that teach directly out of the calculator, which means remove the word teach from that, because then you're not teaching shit. So a lot of the questions are a little bit backwards. They'll ask you to draw a picture after you've done the work when you should have drawn a picture while you're doing it. They'll ask you to figure out the error bound after you've gotten the confidence interval. But we figure out the error bound first because we do it, we do it the right way. Let me see, also in section 8.1. Oh, so let's say I make, let's say I have a X bar of 7 and I get a confidence interval from 4 to 10, right? Is that cool? I make a confidence interval, my X bar is 7. I do all the work. I get a confidence interval for, let's say it's a 95% confidence interval. So how do I draw it? Like that. Oh, shit. Somebody's here. Also, let me see. Oh, going back to what you said, it's best for us to send them to Canvas since you mentioned sending a ring. Yeah, well, no. Canvas, when you upload it to Canvas, it will overwrite your previous submission if you're not doing it correctly. There is a way to put multiple files in. Several people have done that, but other people seem to be overwriting what they've turned in. Email can handle whatever the shit you throw at it. I'm just getting about 3 times as much email as normal because of how we are. And everything, and you don't want to hear this because I know you guys are having a rough time with this stuff too, but everything's taking me about 1.5 times at least as much time to do. So I'm glad I got the quizzes almost all done except Alex, of course, I'm grading yours still. I got it out of the email. So I'll let you know how it goes. The rest of you guys should be able to see your quiz. So if you looked at your quiz already, I finished most of them yesterday and then the rest of them this morning after an exciting trip to the grocery store. I don't know, nothing's easy anymore. So if you have any questions about the quiz, you can ask that right now also. So any questions about the quiz or more from homework? Question 5C, let me see, what was, oh yeah, I'm glad a few of you guys, yeah. So I want to remind you about something. The quizzes, I'm going to take the tests and break them up into quizzes. So the reason it was number 1 and then number 5 and then number 3 is because it used to be 5 on the test and I forgot to renumber it. So I appreciate the fact that it didn't have any excessive smartasses wondering if I knew numbers. So let me see, 5C. Oh, all right. Everybody in 5B on the quiz. Where have I put my, I guess get, oh, eraser is cheap paper towel. All right. Everybody's 5B looks something like this, right? Right? Was it that number? No, but who cares? Everybody had some kind of number there. Close, sure, I don't care. I'm not gonna do your work for you. So that's the probability. So the probability that any group of 5 years had an average greater than 14.7, was close to 0%, right? And then the last 5 years is greater than 14.7. Is that something that was likely to happen if everything is the same as it was? No, no. That's the probability that we get a group of 5 years above 14.7, assuming that mean and standard deviation for the last, what was it, 120 years is still right. So obviously, what is that evidence of then that the average for the last several years have actually gone up, right? Thankfully, well, one year I had that question on the quiz and somebody got very upset at me saying, I know what you're trying to get me to say and blah, 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 whatever. I'm not going to guess what color hat he was wearing, but this is not a political problem. This is a numbers problem, right? It's up to the politics to try to spin the numbers, but the numbers say what they say. Anyway, all right, sorry, I'll stop ranting, sorry. Is that okay for that problem? So part 5C, you can reference the work you did in 5B. That's what I intended. Now, some people for 5C created the max and min usual values, but if you do that for 5C, use the correct spread. You've got to use the spread for groups of 5 years, right? Yes? No? I could do what I want to, Jeff. All right. All right. Anything else about homework or quiz? No, okay. So we're going to get back into that handout that we were working on last time. Let me just show you how far we got and remind you what this handout is. Where did I put you, handout? There you are. Okay, you guys see that? Let me see if I can still see the, oh, Brian. Let me open the door here. All right. You guys all see that, right? The section 8.1 handout over here. Let me see. Turn on chat so I don't miss anybody. Okay. Okay. Oh, let me zoom in. Boom. All right. So we did that part last time, right? We did the dolphin part at the top, blah, 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 blah. Okay. So if you weren't here last time, that's what we did. And then we sort of, I don't think we did, we talked about what this would be. So if you weren't here last time, oh shit. So you better go watch that YouTube video. I'm not going to reteach this, but essentially the idea is if I have a mean that I find from a sample that I take, I am almost certain that is not the mean of the whole population because I just got it from a sample. So that's always going to be an estimate. So what a confidence interval tries to do is to improve on that estimate, to give more information about how certain I am about that estimate. So here we have this here, right? This equation, this is the formula for confidence interval. You want to start at your mean and go up and down so many steps. So if I go the right number of steps to catch 95% of the information, then I will be 95% confident that that interval caught a specific piece of information. In this case, the actual mean. So I love, I hate fish, but I love the analogy about like a fishing net. If I catch 95% of the fish in a pond, I am 95% confident that my net caught a certain fish. And in this case, that certain fish is the real mean. So we start at our best guess, X bar, and then we go up and down, we make our net. And the bigger the net is, the more stuff I catch and the more confident I am that my net catches the real mean, right? Okay, So you throw all the information in. I wanted to be 95% confident. So this is the work we had to do to figure out what the z-score was. Did I show you guys what I call the baby chart? If you look at the positive z-score side in the bottom, what would that be? You could do it, Jeff. Right-hand corner, right? Can you guys see my screen all right? There's a little baby chart. So 95% is 1.96. Woohoo! Now, knowing your instructor, you know I'm going to ask you to make like a 94% confidence interval, and that ain't on there. So you're going to have to know how to do this work right here, right? Okay. So what I want you guys to do is to do part B. Do part B. So it's going to be exactly the same as part A. The only difference is I only want to be 90% confident now. So you have to do this step. You have to figure out what the z-score is going to be, and I just gave you a shortcut to do that. Sorry, I keep moving the screen up and down. I'm going to get sick. So do it. You can do it. Jeff is going a little crazy. Hydration. I don't know if anyone's doing it. All right. Well, let me at least catch up to your attempts to find the z-score. So let's just do it the old-fashioned way. I know you can see it. Oh, that's the worst normal curve I've ever drawn in my life. Oh, well, too bad. So I want to be 90% confident. So this will be, boop. Right? Is that cool? Let me see if I can close some stuff up here because, oh shit, you guys don't want to see that. Actually, you do want to see that. That was the answer key for the quiz. All right. What decimal point should we round to for the error bound? I got you. So really good question. You want to at least have the same number of decimals as the sample mean did. So in this case, I need to have at least one decimal place in my confidence interval because the X bar is 92.6. So you can have more decimal places, just don't have less. Yes, so somebody's telling me exactly. What do you look up in the chart to find this z-score right here, this one? What's below it? What area is this? Yes, there's 90% inside, so there must be 5% on either side because there must be 10% total outside. I keep missing my camera. And if you look up 0.05 in the chart, you're going to get that little asterisk dude that we saw before, and you will get negative 1.645. Negative, Jeff. There you go, buddy. Let me decrease the size of that thing. Not negative this time, Jeff. And so because of symmetry, the other one is going to be positive 1.645. And that is why there is a plus or minus in the equation. That's just so beautiful. Right here, this plus or minus, oh crap, I missed it. Jeff, it's fine, dude. No, it's not. Go away. All right. This plus or minus right there is because of the positive and negative z-score, so it can go both ways. So now, these kind of problems, so it took me forever to get through the idea of these problems. If you were there with me, you can agree, right? But the actual nuts and bolts, they have to tell you almost everything. In this case, the only thing I didn't know was the z-score, and I get that from the confidence level. And then it's just plug and chug. So what am I going to plug in here? X bar was 92.6. Excuse my formatting, but too bad. Plus or minus, let me do this at least. Plus or minus The z-score is 1.645 times the standard deviation was 4.11 divided by the square root of 37. That is what that formula, there you go, computer. That's what that formula looks like. So go ahead and do it. Do it. I highly recommend you do the error part first. I will do it with you. Bum, 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 bum. Jeff is going absolutely crazy. Bum, 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 bum. You guys get to see, it's sort of like all my lectures are sort of like a Zoom diary as I lose sanity through the pandemic. Stay sane until I pass the class, Jeff. Okay, I'll do what I can. So the error piece, barf, come on. Sure, that still works. Let go of it. Thank you. The error piece, what do you guys get for the error? Yeah, I get 1.111. So that in general, you can do 1.11, that's fine. You don't want to round too much until the very end of the problem, right? So don't round too much. Don't go crazy. You got this. Okay, thanks, Victor. Somebody's giving me a, I can't promise you anything. So you just hope if I go crazy, it's in the direction of crazy giving out A's. But we'll see. All right. And now to finish this up, you just have to do 92.6 minus 1.111 and 92.6 plus 1.111. And then you can round it. So if I do 92.6 minus 1.111, I get 91.489. So I'll make that 91.5, right? And if I, Jeff, I was suddenly European. If I do 91.5, I'm sorry, 92.6 plus 1.11, I get 93.7. Okay, how's everybody doing? Is everybody cool with where those numbers came from? Anybody not cool with where those numbers came from? Okay, you're all cool. You're all cool people. Now, what's going to become your favorite part of these problems is writing the conclusion. By the way, let me know if my connection gets wonky. I had one day this week where it was like, you know, and students are like, what are you doing? So just let me know. It could be me, it could be you. All right. So what am I going to write for my conclusion? We are 90% confident. That makes sense. Doesn't matter which way we put the numbers. Oh, intervals always go from smallest to biggest. It would be so weird if you said to somebody, if somebody said, how old can the kid be to get into your program? They could be anywhere from 20 to 12. Who are you? 12 to 20, right? I mean, so we always put the smaller number first. We are 90% confident that the interval that we just made, interval, sure. The interval, 91.5 inches to 93.7 inches, contains the true population, the tour? Sure, Jeff. The true population mean, what was this all about? I forgot already. True population mean length of dolphins? Yes. Dolphin length. So we are 90% confident that the net we made, that our interval contains or even catches the true population mean, in this case of the dolphin's length. It is very important that it's put together in that order. It will seem like semantics, but if you say we're 90% confident that the true mean is in our interval, you are wrong. And I know that I know it seems like I'm being like extra picky for some arbitrary reason, but That makes it sound like the real mean doesn't exist yet. And then we make our interval, and then the mean comes in and falls in or doesn't. The real mean exists. Either we catch it or we don't. And that's why it's got to be worded that way. Hopeful Tai Chi. Okay. All right. So I'm going to turn the sharing off. Have you guys got that? I'm going to assume that's a yes. Okay. Yeah. Okay. All right. The two people that are still with me, they say, okay. All right. So I need to stop sharing so that I can explain this part. So let's do that. How do I stop sharing? Stop. All right. So what if, so our error on that one was, what was it? 1.111, right? A little more than an inch off. What if my weird ass dolphin boss says, it's not good enough, Johnson, I need to be within half an inch. So what do you think is going to happen if I take a larger sample? Should my error increase or decrease? Yeah, we've known since the very first day of class that a larger sample is better. And it has to be randoms. But now when I say we take a sample, it's automatically understood that it's got to be a random sample. If it ain't, all of it is shit, right? So if I have a larger random sample, any errors or any uncertainty in what I see decreases. So let's see what that means mathematically. You guys told me that even my blue marker is giving up on me. The lighting's not too bad, right? I think I finally figured out the lighting. All right, channeling my old theater days. I never did lighting though. The error is this piece. Let me stop for a minute. That's what we said earlier. The very first thing we talked about today was the error is this piece. So I can write the error equals this. True? True, it just is. So you can see mathematically, if I increase n, what happens to e? It decreases because I'm dividing by a bigger number, so this is going to go down. So what I want to do is if my crazy ass boss says, I want it to be within this much, I can do a formula to figure out how big of a sample I have to take in order to meet that demand. So I want a formula that's solved for n. Right now, this is solved for e. But if he gives me an error, be within this much, I'm like, oh shit, I got to figure out what my sample size has to be. So how do I solve this for n? Shit. There's two things that suck about n in this equation. One, it is on the bottom. Two, it's under a square root. There's a nifty thing from algebra, though. Watch this. This is going to, just a little side note, right? No tricks here, right? What's 20 divided by 5? Holy shit. All right, what's 20 divided by 4? Holy shit. Look what's true then. 20 divided by one chunk equals the other chunk. See how these can just switch places and it's still a true statement? So I can just switch places between these two. So if you wanted to do every step, you would multiply by square root of n and then divide by e. But don't you see that just means they change places. It's a very cool little shortcut to learn from algebraic methods. And then the last thing I have to do is to do what? Totally sick, Malachi. It's appropriate adjective for that. What's the last thing I have to do to get n by itself? Square. Yes, I like it. I like one semester a student said divide by the square root. And that made me cry for a little bit. So yeah, you have to square both sides. That is the opposite of square rooting. So now I have that formula. So if somebody tells me, I want you to get within this much, I can figure out how large of a sample I need. So if they give me something and I figure out I need a sample of 100, I'm like, okay, I could do that. If they give me something and I need a sample of 8 billion, I'm like, no, I'm not going to do that shit. So sometimes I call this a feasibility formula. Is it feasible to do this? Even if you don't know what the word feasible means, it's just an idea of whether it's possible or not. Is it within your reach? So let's come back to this. Am I missing anybody? No. Okay. I'm going to share my screen again. I'm suddenly feeling generous again. Pop! Where are you? There you are. Okay. So now you can see this question. How many dolphins? Now watch this. Watch this. I really want, now watch. Up here, when I took 37 dolphins, right? I took a sample of 37 dolphins. I got an error of 1.324, right? So 37, a sample size of 37 makes my error 1.324. Part C says, to be within half an inch, how big of a sample do I need? So obviously I'm going to need a bigger sample, because 37 made it within 1.3 inches or so, and now I want to be within half an inch. Shit. So let's identify all my parts here. Let me see. Oh, I can't see anything anymore. Hold on. There we go. In case anybody has a question or something, let me pull my chat back up. Whenever I share my screen, everything goes freaky. Okay. So notice this. Would you please notice this? It says 95% confidence right there, right? So that's why I was contrasting it with the first question, because that was the 95%. So the Z-score for 95% is 1.96. So I know the Z is 1.96. Come on. Now also, I've got, let me, that doesn't matter, Jeff, it'll be fine. 1.96, get out of there, squared, times, and the sigma's the same. What was it, 4.11? Yeah, 4.11 squared divided by, where'd you go? Now, which part of this is the error? What's the error that I want? Yes, if I put 1.324 in for E, I will get 37, because I already know 1.324 error goes with 37 sample size. Do you see that? They go together. I want to know what sample size goes with 0.5. Did I write that right? Yes. Good job, Jeff. There it is. So for 95% confidence, Z was 1.96. The standard deviation is still 4.11. And now they want me to be within half an inch instead of 1.3 inches. So my sample size is going to get a decent amount bigger. So let's see what this is. Get out of there. So what do you guys get? Anybody get something? Anybody else get something? I'm not going to show you what I got. Yeah, that's what I got. Right? Now, what's wrong with that? I don't want you to become, somebody got 256. I think you just misread that, Alex, right? 259. Let me see how many people get this reference. Don't become Dolphin Dexter, right? I don't want you cutting dolphins up. I don't want you to get 259.57 dolphins. So no matter what that decimal is, round it up. So even if it was 259.03, I would round it up to 260. So over here, let me write down. You could do it, computer. There you go, buddy. This equals 259.57, blah, blah, blah. And then I round that to be 260. So I would need about 260 dolphins. Oh, somebody got my Dexter reference. Thank you. Now I want to see Dolphin Dexter as a cartoon somewhere. 260 dolphins. So 37 dolphins got me to within 1.3 inches. 260 dolphins would get me to within half an inch of the real mean. That goes along with what we knew day one. If I make my sample bigger, 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 I can trust my results more, more, more. That's exactly what this is saying. So this is the math finally catching up with what we knew intuitively. What I meant by is that demonstration. Yeah, I got you, Alice. Let me think. Okay. Any questions on that first side of this handout? We did this part last time, the red part, and then just to make it a Christmas theme for some reason, put the green part. That's what we just did today. Any questions from that side? This is section 8.1, by the way. Did I explain to you before why I'm skipping 8.2 for now? I think I did that on the homework. Didn't I put 8.1, 8.3, 8.2 out of order? It's because 8.3 still uses this. 8.2, we're going to use a different chart for some reason. We're going to use what's called T-scores. And you're like, what? When does it end? What? Stop. I will tell you this. Why would those people do that? I don't know. I'm not even sure what you're talking about there. I will tell you this. We have the Z chart we know already. We're going to get the T chart next time. And then there's going to be one more chart after that, I promise. And that'll be it for charts. There won't be a Z chart, T chart, F chart, W chart. There actually is an F score, but we're not going to talk about that. That's stats too. I'll stop. I'm sorry. People are kind of like, shut up. All right. So let me stop sharing. We need to talk about the idea behind 8.3. Oh, shit. I just have that worked out for some reason. Let me stop sharing. Stop sharing. Oh, okay. So here's the idea behind section 8.3. 8.3 is all about percentages. In fact, are any of you actively keeping up with or unable to stop getting information about the upcoming election? Anytime you hear something about like 42% are going to vote for Biden and 48% going to vote for whatever, at the bottom of the screen or the bottom of the article, you'll see plus or minus 4%. Has anyone ever seen that? Okay, a few of you guys. All right, I know that. No, Lewis is like, I've never seen that shit ever in my whole life. Okay, so let me see. Actually, let me see if I can look up something real quick. I would say talk amongst yourselves, but you can't. Too bad. I want to show you something. This is the best part of the whole thing. Jeff is just looking shit up. Let me see. Oh, shit. All right. Who's talking? How y'all doing? Oh, there you go. Malachi's trying to get something started. Interesting. Okay. God, this is really morbid. Let me see. Here we go. This should be good. Oh, there you go. Some people are talking. I like it. Oh, that warms the cockles of my heart. All right, let me see if I can find. You can do it, Jeff. Come on, buddy. Come on. This is exciting, right? You guys are like, wow, I am riveted. Come on. Study. I swear to God, study. I'm going to have to hurt you. Dadgummit. Fine. All right, sorry. All right, that was exciting. I can't find one real quick. I'm okay, just missing people. Well, the funny thing is, I'm pretty good. Coffee's fueling my life. Yeah, it's true. That's a very good point. Seeing people at the moment is kind of weird. But yeah, I missed the days when it wasn't true. Okay, sorry. What was I talking about? All right, so you will see something like 44% will vote for that, 48% will vote for that, and at the bottom it says give or take 4%. You just will. All right. We should know by now where that comes from. So we have Section 8.1 is all about making intervals for unknown population means. Section 8.3 is all about making intervals for unknown population percentages. Right? How do they figure out? How do they do a poll and figure out what it looks like? How many are going to vote for this? How many are going to vote for that? They actually call people up and say, hey, who are you going to vote for? They actually make it better. They set their questions up better than that. But, and from that sample, they then try to say something about everybody, but then they have to include how far off they think they are because it was just a sample. They didn't talk to me. They've never talked to me. Maybe I am on the do not call list for them. Don't call this guy. He's going to give you his whole opinion. Anyway. So, to get to here before, Jeff, you can do it. We kind of started with this. All right. Right? It's the same thing. I don't know mu, so I find a sample mean. I found a sample mean. That means that's got to change. And then I go up and down a certain number of steps. So this formula is kind of like this formula's daddy. Sure, why not, Jeff? Right? That's where this formula kind of came from. It came from this idea. So we're going to do the exact same thing, but for percentages. So for a percentage problem, I would talk to a certain number of people. I would get a certain number of successes, and then I can calculate P and Q. So it's like a binomial problem, right? So if I ask people, hey, are you going to vote in the election? They can say yes or no. So it's a P and a Q, right? So when I write this symbol, though, when I write that symbol, that is a population percentage. The same way that mu is a population mean. When I have a sample mean, what letter do I use? X bar. So when I have a sample percentage, what letter do I use? You're going to love it. P hat. P hat. Yeah, I think the book uses, does the book use P bar? I always forget about it. P bar has a completely different meaning. I really hate that. It's P hat, everybody. It's P hat. So P hat, or maybe that was a guess, Lewis. That's not a bad guess. You got to put something on its head, right? X gets a bar on it, P gets a hat on it. So yeah, P hat is the one you don't want to accidentally wear. So P hat means sample percentage. Okay, maybe. So the difference would be if I said 71% of all Americans are hating being quarantined, right? Because 29% love it. 71% of all Americans hate being quarantined. That would be P. If I said I talked to 80 people and 71% of them like being quarantined, that would be P hat. Because it's talking about a sample. So it's the exact same relationship between these two as there is between those two. Okay. Some of you guys are looking off. So help me out. What was the mean formula for an NPQ problem? It was NP, right? And the standard deviation was square root of NPQ, correct? So what will X bar be now? What will the formula for X bar be? Well, if mu came from n times population percentage, X bar is going to come from n times sample percentage, right? Yep. All right. And then so here, my sigma sub x bar is going to be square root of n p hat q hat. I like it. Maybe, maybe. So the same way, so forgetting about this for a second, the same way we got there, I've got to use x bar instead of mu, and now I see that x bar is n p hat. Right? X bar is n p hat, give or take z. And what's the standard deviation going to be? It's going to be square root of n p hat q hat. So I still start from this basic idea, but now I want to incorporate percentage formulas, right? Because that's what I want. I want to think about a percentage. Now, this is still not a percentage right here, right? What's the extra shit that I don't really want? I don't want that n. Believe it or not, that's trying to be an n. Okay. All right. So just so you know, we're in the middle of the derivation of the formula that we're going to use. So if you're not 100% on board with everything that's happening at the moment, I wish you could be, but this is just the derivation to get to the formula, right? So it is important, but it's not something you'll have to be able to do yourself. Now, let me put this here. What does this try to do? What does that try to capture? What does that try to capture? Yeah, the population mean. It doesn't try to capture the error. The error is a part of it, but it tries. So if I write it like this, is that, do you guys see what I'm trying to? No, you don't, because I can't write when I'm turned around like this. There. So mu is captured by this, is what we hope, right? So let me write that same thing for this. I want mu, which is NP, I want it to be captured by this mess here. Okay, I really want you guys. Mu is captured by this. So mu NP, I want it to be captured by this. Okay. So here's the step that's really interesting. I don't want n there, do I? I want to be able to say like 80%, give or take 3%, right? So that n is extra. I don't want that to be there. So let me divide by n. Now my percentage, that's what I want. I want to catch the population percentage. The population percentage is caught by p hat, give or take. Let me ask you this real quick. Can I cancel those n's? Those n's there, can I cancel them? Definitely not. Because that's not even an n. That is half of an n. That's the square root of n. You can't divide unless they have the same root, right? Well, what's the square root of n squared? What's the square root of n squared? I don't know. Oh, there we go. Yeah. So therefore, I can replace n with the square root of n squared. I know somebody out there right now is going, I don't know what the all right. But that's true, right? I can replace n with the square root of n squared. But now these both have a square root. I can reduce. So one n is going to cancel. So my formula ends up being p hat plus or minus z square root of p hat q hat over n. I will rewrite that. Woo! Wow. So that, if I ask you, make a confidence interval for the true percentage of whatever, you know you're going to use this formula because it's got the plus or minus, which is an interval, and it's talking about percentages. Coolness. So let me see. All right, let me try to kill some of this stuff before I. Bum 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 bum. This is so exciting. Barfity puke. Come on, come on. Technology. I tell you what. Sorry. Oh my God, help me. Oh, that's right. Okay, before I even do this, maybe I'm not even going to get to that because I got a big thing to talk about. That's true. I always forget to talk about this. And it's the biggest part of this whole thing. All right. So one more thing to talk about here, and then I think we'll call it a day because it's already 10 till 10. When I want to use this, formula, what needs to be true before I can use it? I know that's maybe that's a little too weird of a question. If I want to make a certain % confidence interval, how do I find my z-score? What do I use to find it? This guy. So let me ask again. Before I can do this, what do I need to know is true? You're like, nobody say anything. Maybe he'll stop. Yes, it has to be normal. So either it just says it's normal, right? Either it just says it's normal, and then it doesn't matter what sample size is. Or if it doesn't say it's normal, then n's got to be greater than 30, right? Okay. What about this guy? What about this guy? I need to have a way to make sure he's normal too, right? The way that we wish we could do with anybody we happen to come across in real life. I need to have a test to make sure this guy is normal. So for means, the test is n greater than 30. We got that test. Yay. We got to make a test for this guy. So let me see. Oh, if I would have been more on the ball. Jeff doesn't care because nothing's easy anymore. Let me see. Where did I put you? You could do it, Jeff. So let me show you something that should look familiar. All right, let me share my screen. Get out of the way. Where'd you go? There you are. Does this look familiar? Pop. Do you guys see that? Right, the Mayan pyramid there. That's what it looks like to me. Oh, I get some chats. Let me see. Yeah. Okay. Does this look normally distributed? Oh, you got it, Alex. Thank you. Does that look normal? Yes, the answer is yes. Because why does it look normal? What is it that you can tell immediately that it looks normally distributed? There's a few different answers you can tell me. What tells you this looks normal? There's a few different answers you can tell me. If you symmetry, I like it. Now give me something else, because uniform is symmetric, and that's not normal. Outliers at polar opposites, I like it. Meaning the highest bar is in the middle. Okay, so why is the highest bar in the middle for this problem? Because what was the mean for this problem? It was 7, right? N times P, 14 times 0.5 was 7. And the highest bar should be equal to or close to the mean, because what's another name for the mean? Expected value. So the mean in this case was 7, which was right in between the lowest and highest, right? It went from 0 to 14. So 7's right in the middle. So it doesn't have room to go up and then come back down. All right, right? Do you guys see that? Do you guys get that a little bit? So watch this. Let me contrast that. What if the mean, stop sharing. Aha. What if the mean would have been, what if my there it is. What if my, I'm a Ghanaian. What if my coin, that's what it was. What if my coin had been tampered with so that it got less heads? Let's say that it gets 1% of the time it's heads now, right? So it's not a normal coin. It's a tampered with coin. My mean then would be 0.14. Yes? Stay with me now. We're almost done. Even if I don't get done, we're almost done anyway. Therefore, where would the highest bar be? It used to be 7 when it was a normal coin. It was right in the middle. It was 7, so it had room to go up and room to come down. Where's my highest bar now? Close to 0.14. So like it's 0. That's my highest bar. Does that have a chance to be normal? No. Nah, no. Try again. Too bad. Fail. Pun. All right, so here's the, just to get to this, NP. So I want to pull it away from that wall. It's got to be away from that wall. So NP has got to be at least 5. Does that make sense? Because if the mean is right on that wall, there's no way in hell it can go up and then come back down. There's no room for it. So I've got to pull it away. It's got to be at least 5 because then it's got room to go up and then come back down. There's another wall, though, on the other side, and that's controlled by NQ. So these two together take the place of this for a percentage problem. So this is about means. N greater than 30. I know the means are normally distributed. This is for percentages. If these two are true, right? If they're both at least 5, that means that it's in the middle somewhere, so it's got room to come up and room to come down. That actually is such a beautiful, almost freakily simple idea. It's just so awesome. Why is it 5 exactly? I can't get into that shit. So they did some, sort of like the same way they came up with 30, was they ran a, like millions of iterations of examples, and then they figured out what the best one, about the best place was. Oh, so for example, let me share my screen one more time and then we'll be done. Where'd you go? There you are. No, not that one. This one. Oh, man. All right, so let me see if I can. Anyway, I'm giving away some stuff. See right here, it says check NP, NQ. And they're hats because we don't even know what P and Q are. You just got to check to see what N times P and N times Q have. Make sure they're at least 5. It takes the place of N greater than 30. N greater than 30 only works for means. NP had NQ. NP and NQ greater than or equal to 5, that works for percentage problems. So obviously, we'll do more examples of that next time. For now, though, I think that's enough. Okay, so today you actually don't have a quiz to worry about. Isn't that crazy? So when's the next quiz? I don't know. We'll talk about that on Tuesday. Anybody have any questions or anything? If anybody wants to hang out and ask some questions, feel free. Otherwise, you can log out. And this is always exciting for me. This is when I find out who's really here and who turned it on and then went back to sleep. Does anyone have questions or need to? Let me see. See ya. Wouldn't want to be. I understand. Thank you. Oh, Samantha, you there still? I never got back to your email. I guess you figured out, because you emailed me about a calculator or something, right? apparently figured gotta fix the link. Yeah, go ahead, Malachi. Oh man, I'm sorry. You bought a new one. Okay. Well, whatever works. All right. When are test corrections due? Oh, I don't know. Did I not put a due date in the Canvas for the test corrections? Let me see. In general, I'm gonna err on the side of more leniency. But I will put some due dates in here, and if you really should get homework done before the quizzes happen. You should try to get your corrections done as soon as possible. But let me see, did I not put a, let me see, test one corrections? Is that what you're talking about? Test one corrections? Is that what somebody's asking me about? Oh, Alondra, the graded quiz is up in Canvas. If you log in, you should be able to see your graded quiz. No due dates for 6 and 7. I mean, they should actually be done. Let me see here. And again, it's a combination of trying to be kind of lenient with you guys and also just not keeping up with turning everything on in Canvas, right? It's a combination of those two things. So yeah, test 1 corrections. I did put a due date in there. They're past due now. Yeah. Let me see. I saw that in no due dates. Okay. Thank you. You're welcome. On the quiz, the first problem adding up to, oh, we talked about exactly that happening. I know it seems like about 7 years ago. But yeah, when you did relative frequency, did it always have to add up to 100%? If it didn't add up to 100%, did that mean you were completely wrong when we did relative frequency tables? No, it was fine. Why did it sometimes not add up to be 100%? Because of rounding. Is 1.0001 very far away from 1? No. Therefore, it was valid. It was just a rounding. If you get like, they add up to be 1.1, like 110%, screw that. That's invalid. That's insane. But 1.0001, that's because of rounding. Yeah. So it was completely valid. Yes. But you had to say that. A lot of people just said the sum was 1 because they knew what to say. But I told you I was going to do that. I don't know if you guys remember. I told you I was going to do that. I did that to make sure that you actually checked it and didn't just say what you knew you had to say. Do we have enough information to complete 8.3 homework? Yeah, Alex, basically we're going to do more examples of it, but you actually have everything you need to start doing 8.3 homework. You really do. It still uses the z-score chart. You know what the check is now, the NP-NQ thing. You find the z-score you need the same way as always, right? So you're able to do everything you need. But if you don't want to start 8.3 homework yet, that's fine. We'll do more examples next time. Can the minimum, yes, totally, of course. Yeah, the minimum value could be negative. Yeah, because it's not based on measurements, it's based on theory. So even if you can't have a negative value, the minimum usual value could be negative. Yeah, which means there's no real minimum then in that case, right? If the minimum can only go down to 0 and your minimum usual is less than 0, then there's nothing that would be too few. Does that make sense? So that's all a negative usual value means. Yeah. By test corrections are, quiz 4 or 5 corrections. I haven't even put the, some people are uploading them into the quiz 4, quiz 5 containers. I haven't even put like a quiz 4 correction, quiz 5 correction place. Those used to be due by the day of the next test. And now there aren't any more tests until the final. So I think I'm probably going to honor that, but my God, please turn them in before that. So I'm not grading a giant stack of stuff at the final exam time. Please. Thank you. Anything else, guys? Or are we just all not wanting to miss something? Or is somebody, I wonder how many of you guys are actually in bed right now sleeping. Is anybody in bed right now sleeping? Yes, I am. Okay. I'm actually in bed right now sleeping. This is a video. I just kind of guessed what your questions would be. It's really, is that freaking you out? All right. That was a joke for me. Okay, I mean, that's all I got, guys. So if you have no more questions, I am going to shut the room down because some of you guys are freaking me out. I don't know if you're really here. All right, I'm going to close the room. So I'm going to see you guys next week. Just keep in touch if you have questions. Okay. Bye, everybody.